Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out the practice questions from the Mathematics Knowledge Subtest of my 8th full-length AFQT practice test. In case this is your first time finding my YouTube channel, I quickly want to mention this. I recently created a website called ASVABapp.com. There you can take 8 full-length AFQT practice tests, including this one. If for some reason you don't want to take this practice test on my website, you're more than welcome to work out these problems alongside me here on YouTube. In that case, I'd recommend that you pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a reference sheet or a calculator on the ASVAB, so regardless of where you take this practice test, try not to make use of any of those resources. Finally, I want to say this. In the description of this video, I'm going to include timestamps that will be associated with each question. Next to the timestamps is going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if you feel as if you need more help with one of these problems, again, just check the description of this video, and there you'll find links to additional resources. So all that being said, let's go ahead and get started with this practice test. All right, so this first question says evaluate the expression using the given values. We have 4x squared minus y to the third when x is 5 and y is -1. On the ASVAB, you are going to have scratch paper, so not surprisingly, I'm going to copy this one down as if I was writing on my own scratch paper. So I'm going to start by copying down the algebraic expression that was given, notably 4x squared minus y to the third. And in addition, I'm going to note that the problem said let x be 5 and y be -1. And let me go ahead and move down a little bit. The next thing I'm going to do is substitute 5 in for x and -1 in for y. So this becomes 4 times 5 squared minus -1 to the third. All right, so since there's quite a few operations going on in this expression, it may be helpful to use the order of operations to decide what to do next. Again, the order of operations is given by the acronym PEMDAS, or please excuse my dear Aunt Sally. This tells you the order in which to simplify algebraic expressions. You do what's in parentheses first, exponents next, multiplication and division as they appear in the expression from left to right, and then finally you work out addition and subtraction as they appear from left to right. Let's look through this expression one more time and see what we have. We have exponents, notably 5 squared and -1 to the third. There are no parentheses. And then we have multiplication, 4 times 5, and negative times -1. And then finally, we just have subtraction. So in this case, we're going to work out our exponents, and then we'll go from there. So I'm going to do those off to the side. Again, we have 5 squared, which is the same thing as this. 5 squared is 5 times 5. 5 times 5 is 25. Likewise, we have -1 to the third. That's the same as -1 times -1 times -1. All right, so you have to be very careful as you work this out because a negative raised to an odd power is going to result in a negative. A negative raised to an even power is going to result in a positive number. And let me explain why. Let's just go ahead and work this out. -1 times -1, a negative times a negative is positive, so -1 times -1 is +1. Then we have +1 times -1. A positive times a negative is a negative. +1 times -1 is -1. So this becomes 4 times 25 minus -1. All right, so let's take a look and see what we have left. Again, there were no parentheses. We took care of our exponents. Right now we have multiplication, notably 4 times 25. And then we have double subtraction. Well, minus minus is the same thing as plus, so that's really addition. All right, so we're going to take care of our multiplication first, and then we'll work on that addition last. 4 times 25 is 100, so this is 100 plus 1. 100 plus 1 is 101. So the answer to this one is C, 101. Again, these problems are difficult because if you don't know your order of operations, you might have simplified this algebraic expression incorrectly. So if you need more help with this, check out my video called Evaluating Algebraic Expressions. In that video, I work out about 20 of these problems. Okay, so that's that one. All right, number 2 here says, what are the factors of 2x squared minus 4x minus 16? Again, not surprisingly, I'm going to start by copying down the expression here. We have 2x squared minus 4x minus 16, and we want to factor this. Well, it should be immediately clear that 2, 4, and 16 have a common factor of 2. So we can factor out a 2 from this, and this becomes x squared minus 2x minus 8. All right, so now this x squared minus 2x minus 8 is probably something we can factor. As a matter of fact, it's a quadratic equation with a leading coefficient of 1. So we know that if we can factor this, it's going to look like this. And now we're looking for two factors that multiply to negative 8 and add to negative 2. Well, that's going to be plus 2 and minus 4. Again, positive 2 times negative 4 is negative 8. 2 minus 4 is negative 2. All right, so that's how we factored this one. And as we can see, the answer to this one is A. You have to be very careful as you look through the answers here. You can see that this one has a negative 4 and a positive 2, but it doesn't have this 2 in front of it. And this one is plus, plus. So I write these questions to see if you're careless in selecting your answers. Again, make sure you read through all the answer choices before you pick one on the ASVAB. They will write the answer choices such that they will be a little bit tricky to read through. So make sure you take your time as you answer these questions. But that's that one. Pretty simple problem. All right, number 3 here says, what is the area of a parallelogram? Area equals base times height. If it has a base of 5x plus 1 and a height of 3x plus 7. All right, so I'm not sure if the ASVAB is going to give you this formula to find the area of a parallelogram. And so if you look on my reference sheet on my website, you'll see that this is one that I recommend you memorize. It's very easy. Again, the area of a triangle is 1/2 base times height. Area of a parallelogram is base times height. That's how I remember it. But that said, let's go ahead and work this one out. We want to find the area of this parallelogram, and according to the problem, the formula to do that is area equals base times height. We know what B and H are. We're told this parallelogram has a base of 5x plus 1 and a height of 3x plus 7. So all we have to do is plug those things in accordingly. This becomes 5x plus 1 times 3x plus 7. Unfortunately, that's not one of our answer choices, which means we're actually going to have to use the distributive property or the FOIL method to expand this accordingly. The distributive property says take 5x and multiply it here and here. Then it says take this 1 and multiply it here and here. So that's what we're going to do. And in case you're wondering, you could get more practice expanding polynomials like this by watching my video called Multiplying Polynomials. I think I work out 20 practice problems in that video, including some that are very similar to this. So if you need more practice with what I'm about to do here, take a look at that video. But that said, you can see the first thing we're going to do is 5x times 3x. So that's going to be 15x squared. Then we're going to do 5x times 7, which is going to be 35x. Then we're going to do 1 times 3x, which is just 3x. And then we're going to do 1 times 7, which is just 7. We have to combine like terms to reduce this further. 35x and 3x are like terms, so this becomes 15x squared. 35, 36, 37, 38, so this is 38x plus 7. All right, so that is that one, and we can see that that answer choice is B in this case. All right, so number 4 here says, what is 5y squared plus 2xy minus 9 subtracted by 2y squared plus 2xy minus 3? So for this problem, we're subtracting polynomials. More specifically, we're subtracting 5y squared plus 2xy minus 9 by this second polynomial. You have to be very careful as you set this one up because we know we're subtracting, so we're going to do subtraction, but we're going to have to put this second one in parentheses because we're subtracting by everything in this second polynomial. So this is minus 2y squared plus 2xy minus 3. All right, so that's the setup. But in reality, what we have to do now is take this negative and distribute it here, here, and here. This is where a lot of people would get this problem wrong. They would just do minus the second polynomial. You have to take the negative and distribute it to each term in the second polynomial in order to get this correct. All right, so let's go ahead and do that. Again, this is 5y squared plus 2xy minus 9. Negative times positive 2y squared is negative 2y squared. Negative times positive 2xy is negative 2xy. And then negative times negative 3 is positive 3. All right. So now that we've done that, let's go ahead and reduce this polynomial by combining like terms. What are like terms? Like terms have the same letter variable raised to the same power. So for example, if I had 5x squared and 10x squared, we would say our letter variable is x, and they're both raised to the same power, 2 in this case. So those would be like terms. That said, if I had 10x to the third and 5x squared, although they have the same letter variable, they're raised to different powers. This one's raised to the second power, whereas this one's raised to the third power, so they would not be like terms. All right, and if you watch my video on adding and subtracting polynomials, I do spend the first 10 minutes of that video discussing what like terms are. So if you need more help with that, check out that video. With that said, let's get back to this problem. Again, we're combining like terms. So the first one we're going to look at is 5y squared. Again, we're looking for the variable y raised to the second power. We can see that that's right here. So this is 5y squared minus 2y squared, which is going to be 3y squared. Typically, once I combine like terms, I like to cross them out. All right. And our next pair of like terms are going to be 2xy and negative 2xy. 2xy minus 2xy is nothing, so those actually just go away. They become 0. And then finally, we have negative 9 and positive 3. Negative 9 plus 3 is negative 6. All right, so that's the answer to this one, 3y squared minus 6, which we should see is B. All right, so that's that one. Again, you have to be very careful when you subtract polynomials. If you don't distribute that negative to all the terms in the second polynomial, you will get the question wrong. All right, so that's that one. All right, so number 5 here says, if C is 5, then what is F? Use C equals 5/9 times F minus 32. All right, so in case it's not obvious, C refers to Celsius and F refers to Fahrenheit. So for this problem, we're converting from Celsius to Fahrenheit. That said, we're only given this formula. C equals 5/9 times F minus 32. So let's identify what's given. We're told C equals 5, and we want to know what F equals. So in other words, I'm going to have to rearrange this equation such that I set it F equal to something by itself. But before I do that, let's go ahead and substitute 5 in for C right there. So this becomes 5 equals 5/9 times F minus 32. Again, we're solving for F, so we want to get F equal to something by itself. The first thing we want to do is get rid of this fraction right here of 5/9. In order to do that, we're going to multiply it by its reciprocal of 9/5. And we're going to do that to both sides of the equation. This crosses out here and here, leaving you with f minus 32 on that side. But now we have to do 9 over 5 times 5. All right, if you haven't worked with fractions in a while, that can be kind of intimidating. But that said, let me work it off to the side right here. We have 9 over 5 times 5. Well, first things first, we can write 5 as a fraction by placing it over 1. And then we can say 5 goes into 5 one time, 5 goes into 5 one time. So this becomes 9 over 1, which is just 9, times 1 over 1, which is just 1. 9 times 1 is 9. All right, so again, we can do that very quickly here. Place this over 1, cross this out, cross this out. This becomes 9 over 1, which is just 9. And now we're just solving for f. All we have to do now is add 32 to both sides. This crosses out here, leaving you with f on this side. 9 plus 32 is going to be 41. And in math, it's customary to write the variable for which you solved on the left. So this is f equals 41, which is answer choice A. All right, so that's that one. Make sure you can convert from Celsius to Fahrenheit. I'm pretty sure that question does show up frequently on the test. Then again, the ASVAB is a computer adaptive test, so you may see it, you may not see it. Regardless, it's good to know how to do this for the test. All right, so number 6 here says, find the slope of the line that passes through the points -12, -5, and 0, -8. If you look on my reference sheet, the very first formula is in reference to finding the slope of the line. And it says m refers to slope, is equal to y2 minus y1 over x2 minus x1. All right. And if you haven't done this in a while, you might be saying to yourself, what is x1, y1, x2, y2? Well, those are the values in your ordered pairs. Again, in this problem, we were given the ordered pairs -12, -5, as well as 0, -8. All right, so this is x, so we'll call this x1, which means this is y1, which means this is x2, and this is y2. So all we have to do is substitute those values into this formula and reduce it accordingly. So let's go ahead and do that as our next step. y2 is right here, it's -8, minus y1. y1's right here, it's -5, so this is minus -5 over x2. x2's right here, it's 0, minus x1, which is right here, it's -12. All right, so minus minus in math becomes plus. So let's go ahead and take care of that next. So this is, in reality, this is -8 plus 5 and 0 plus 12. -8 plus 5 is going to be -3. 0 plus 12 is 12. If we take a look, we can see that that's not one of our answer choices. So it should be obvious that we can reduce this fraction by dividing the numerator as well as the denominator by 3. -3 divided by 3 is -1, and 12 divided by 3 is 4. So the slope in this case is -1 over 4, which we can see is answer choice C. All right, so that's that one. In addition to knowing how to find the slope of the line, you also have to know how to write the equation of the line for the ASVAB. So make sure you can do both of those things. Again, in my video called Writing Equations of Lines, I break down everything you need to know about lines to be successful on the ASVAB. So that's that one. So number 7 here says, which of the following is a prime number? We have 99, 51, 53, and 111. All right, so I'm going to write these numbers down. Okay, we have 99, 51, 53, and 111. A number is considered prime if it's only divisible by 1 in itself. So for example, the number 5 is considered prime because it's only divisible by 1 and 5. That said, finding the prime number in a series of numbers like this is a little bit more challenging. And if you watched my video called Prime Numbers and Divisibility Rules, you would already have a good idea as to how to start this problem. Again, if a number is divisible by 2, 3, 4, or 5, then it's not prime. And thankfully enough, we can use divisibility rules to quickly check to see if these numbers are divisible by 2, 3, 4, or 5. All right, and let's start with 3. In my video on divisibility rules, I said this: if the sum of the digits in a number is divisible by 3, then that number is also divisible by 3, which means it's not prime. So what is 9 plus 9? 9 plus 9 is 18. 18 divided by 3 is 6. Since the sum of 9 plus 9 is divisible by 3, 99 is also divisible by 3, which means it can't be prime. All right, what's 5 plus 1? 5 plus 1 is 6. 6 divided by 3 is 2. Since the sum of 5 plus 1 is divisible by 3, that means 51 must also be divisible by 3, and therefore it's not prime. What about 53? 5 plus 3 is 8. Is 8 divisible by 3 evenly? It's not. So I know 53 is not divisible by 3. What about 111? Well, what's 1 plus 1 plus 1? 1 plus 1 plus 1 is 3. 3 divided by 3 is 1. So 111 must also be divisible by 3, and therefore it's not prime. So using the divisibility rules for 3, I quickly determined that 53 is our prime number here. All right, so that's that one. Again, I strongly encourage you to watch my video called Divisibility Rules in Prime Numbers. Again, it will help you with mental math, and in addition, it will help you in identifying prime numbers very quickly. All right, so that's that one. All right, so number 8 here says, what is the product of the reciprocals of 2/3, 1/8, and 5? All right, so first things first, we have to find the reciprocal of 2/3, 1/8, and 5. Well, reciprocal just means exchange your numerator and denominator. So the reciprocal, and I'll write it out, we're just going to exchange these two. So the reciprocal of 2/3 is 3 over 2. The reciprocal of 1/8 is 8 over 1. Again, we just exchanged our numerator and denominator. And finally, what about 5? Well, you've seen how to approach this in this video already. Again, we can write a whole number as a fraction by placing it over 1, and then we're just exchanging our numerator and denominator. So the reciprocal of 5 is 1 over 5. All right, so those are our reciprocals, and we want to find the product of them, which means we want to multiply them together. So we're going to do 3 over 2 times 8 over 1 times 1 over 5. When you multiply fractions, you simply just multiply straight across. So this becomes 3 times 8 times 1 over 2 times 1 times 5. 3 times 8 is 24. 24 times 1 is 24. 2 times 1 is 2. 2 times 5 is 10. All right, so this is 24 over 10. Unfortunately, we can see all of our answer choices are written as mixed numbers. So we're going to have to convert this improper fraction to a mixed number. But before we do that, we want to reduce this improper fraction. And we should see that 24 and 10 can both be divided by 2. 24 divided by 2 is 12. 10 divided by 2 is 5. All right, so now let's convert this improper fraction to a mixed number. And the way we do that is via long division. We actually read this as 12 divided by 5. And we start by asking ourselves, how many times does 5 go into 1? It doesn't. How many times does 5 go into 12 without going over? That's going to be 2 times, given that 2 times 5 is 10. 12 minus 10 is 2. All right, so we have enough to write this improper fraction as a mixed number. This 2 is going to be our whole value. This remainder of 2 is going to be our numerator. And this 5 is going to be our denominator. All right, so our answer in this case is 2 2/5, which we can see is answer choice A. All right, so quite a bit of work involving fractions there. If you need more help with that, please watch my playlist called A Review of Fractions for the ASVAB. Again, a lot of people struggle with fractions, but if you watch that playlist, you'll have no problem working these out in the future. All right, so that's that one. All right, so number 9 here says f2 to the x equals 64, then x equals. So we have 2 to the x being 64. At first glance, this problem seems challenging, but this x basically says, what power is 2 raised to give us 64? And if it's helpful, we can think about it this way. 2 raised to the second power is the same as 2 times 2, and 2 times 2 is 4. 2 raised to the third power is the same as 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. All right, so we can see the pattern here. What is 2 to the fourth power? That's the same as 2 times 2 times 2 times 2. Let's work that out. 2 times 2 is 4, times 2 is 8, times 2 is 16. Well, what about 2 to the fifth power? That's 2 times 2 times 2 times 2 times 2. That is 2 by itself 5 times, so let's work that out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. What about 2 to the 6th? Again, that's 2 multiplied by itself 6 times. So that's 2 times 2 times 2 times 2 times 2 times 2. Let's see what this gives us. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So clearly, x in this case has to be 6, because if we raise 2 to the 6th power, we get 64. So the answer to this one is A, 6. All right, so that's that one. All right, so number 10 here says, what is the length of the diagonal of a rectangle that has a base of 12 and a height of 5? All right, so we have a rectangle, so let's draw one of those. And according to the problem, we know this rectangle has a base of 12, so that's right here, and a height of 5. And according to the problem, we want to know the length of its diagonal. Well, the diagonal is from this corner to this corner. And it may not be obvious, but when you draw a diagonal on a rectangle, what you actually get is 2 right triangles. All right, so we can see that one of the right triangles looks like this. Has a height of 5 and a base of 12. Well, what do we know about right triangles that will help us figure out what this length is, which, as we can see, is the same length as this diagonal? We can actually use the Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared equals c squared, where a and b refer to the legs of the right triangle, and c refers to the hypotenuse of the right triangle. Well, how do you identify the hypotenuse? The hypotenuse is always directly across from the right angle. So this length right here is our hypotenuse, and we can see that that is the same length as the diagonal on this rectangle. So in other words, if we solve for c, we'll also be solving for the length of this diagonal of this rectangle. So let's go ahead and do that. Again, 12 and 5 are our legs, so I'm going to call A 12, and I'll let B be 5. Let's plug those in accordingly. This becomes 12 squared plus 5 squared equals c squared. 12 squared is 144. 5 squared is 25 equals c squared. From experience, I already know what this is going to add up to, but that said, we can work it off to the side if we need to. This is 144 plus 25. 4 plus 5 is 9. 4 plus 2 is 6. 1 plus nothing is 1. So this becomes 169 equals c squared. Again, we just want c, not c squared, so we'll take the square root of both sides. This crosses out here, leaving you with just c on this side. Square root of 169 is going to be 13. You have to memorize your squares from 1 to 20 to be successful on this test. So we can see c is 13, which means this hypotenuse is 13, and the length of this diagonal, therefore, is 13. So the answer to this one is B, 13. You had to use the Pythagorean Theorem to find the length of the hypotenuse, which is also the length of the diagonal of this rectangle. All right, so that's that one. All right, so number 11 here says, how much money would you need to invest in an account that receives 20% in annual interest and is compounded annually to have $12,000 in the account after 1 year? Use A equals P times 1 plus R over N to the NT power. A is the amount in the account, P is the principal, that is the amount you invest, R is your interest rate in decimal form, N is the number of times interest is compounded per year, and T is the time of your investment in years. All right, so let me just stress this. If you see a problem involving compound interest on the ASVAB, you're not going to have to memorize this formula. More than likely, it's going to be given to you. That said, you have to be confident in your ability to work with the numbers to solve a problem like this. So let's get started, not surprisingly, by copying this formula down. Again, it's A equals P times 1 plus R over N to the NT power. And we have to go back through this problem and identify what we're solving for, as well as which of these values were already given. All right, so again, A is the amount in the account after your investment runs its course. Well, we want to have $12,000 in the account after our investment runs its course. So A in this case is 12,000. Let's go ahead and plug that in accordingly. P is the amount you invest. And this question says, how much money would you need to invest in an account? So we're solving for P. That's what we're going to be solving for. So we're going to leave that as P. 1 plus R, according to the problem, is your interest rate in decimal form. That's right here, 20% in annual interest. The decimal form of 20% is 0.2, so this becomes 0.2. N is the number of times interest is compounded per year. Well, we're told right here it's compounded annually, which means 1 time per year. So N in this case is 1. Again, N is 1. And T is the time of your investment in years. Well, after 1 year. So N, or T in this case, is 1. All right, so we've plugged everything in. All we have to do is simplify this expression and solve for P. And it's not as difficult to do as you think. Let's just take it one step at a time. This becomes 12,000 equals P. Remember your order of operations. Please excuse my dear Aunt Sally. We do what's in parentheses first. And as you can see, we have 1 plus 0.2 over 1 in parentheses. So we're going to take care of that. This becomes 1 plus 0.2 divided by 1 is just 0.2. And then 1 times 1 is just 1. All right. So let's keep working this out. This is 12,000 equals P. 1 plus 0.2 is 1.2 raised to the first power. So we took care of what's in parentheses. We have an exponent to deal with, raised to the first power. Well, anything raised to the first power is just that number. So 5 to the first power is just 5. 6 to the first power is just 6. So 1.2 to the first power is just going to be 1.2. So this is P times 1.2. We took care of our exponent. Again, now we're just solving for P. So we don't need our order of operations. We just have one operation left to solve for P. That is, we're going to divide both sides by 1.2. This will cross out here, leaving you with just P on this side. And as we can see, P is 12,000 over 1.2. We could read this as 12,000 divided by 1.2. And believe it or not, this is actually pretty easy to do. We are dividing a whole number by a decimal. The key to this is remembering that if the decimal's outside the division bracket, you have to shift it such that that number becomes a whole number as well. So I'm going to shift this decimal in 1.2 one time to the right, such that it becomes 12. And then I'm going to have to shift the decimal in 12,000 a corresponding number of times and add a zero placeholder. So this becomes 120,000. Now this math is actually very, very easy to do. 12 goes into 12 one time, and we'll just bring up these zeros. 12 times 10,000 is 120,000 with no remainder. So P in this case is going to be 10,000, and in math, it's customary to write the variable for which you solved on the left. So in other words, we would have to invest $10,000 in this account, given this interest rate and how many times it's compounded, to have $12,000 in the account after 1 year. All right, so that's that one. Again, these problems are not very difficult, but that said, you have to be very careful as to what you plug in where. And in addition, you have to be confident in your ability to work out the arithmetic to get these questions correct. All right, so that's that one. Again, I do have a whole video on calculating compound interest, and I think I work out about 7 or 8 examples in that video. So please check out that video if you need more help with this one. All right, so number 12 here says, what is the height of a triangle that has a base of 20 and an area of 100 square feet? All right, so we're told that this triangle has an area of 100 square feet and its base, our B, is 20. Well, to figure out its height, we can actually use the formula to find the area of a triangle. To find the area of a triangle, you use area equals 1/2 base times height. Again, we know what B is and we know what A is. A is 100, so we'll substitute that in for A, and B is 20, so we'll substitute that in for B. So this becomes 100 equals 1/2 20 times H, where H refers to height. Again, this is actually very, very easy to work out. This becomes 100. What is 1/2 of 20? That's going to be 10 times H. Again, we're solving for H, so we'll divide both sides by 10 now. This crosses out, leaving you with just H on this side. 100 divided by 10 is 10. So the height of this triangle is 10 feet, which is answer choice C. You do have to memorize this formula for the ASVAB. That is, you have to know how to find the area of a triangle. All right, so that's that one. Again, pretty much every formula that's on my reference sheet you have to memorize. Otherwise, I'll tell you not to memorize it. So number 13 here says, if the radius of one circle is 20 inches and the radius of a smaller circle is 10 inches, how much more area does the larger circle cover than the smaller one? Use 3.14 for pi. So this problem is actually fairly simple. All we're going to do is find the area of the large circle, and we're going to subtract that by the area of the small circle. On my reference sheet, there's a list of formulas you need to memorize, and one of them is about finding the area of circles. That formula is area equals pi r squared. All right, so this is going to look like this. The area of the large circle is going to be pi r squared minus the area of the small circle. Again, that's pi r squared. We need to figure out what r is. Again, r refers to the radius of the circle, and we're told what each of those is. Again, the radius of the big circle is 20, so this becomes pi 20 squared minus pi. What's the radius of the smaller circle? It is 10. So this is pi 10 squared. All right. You should know that 20 squared is 400. But in case you didn't know that, we can always work it off to the side. Again, 20 times 20 is 0 times 0 is 0. 2 times 0 is 0. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 0 is 0. 2 times 2 is 4. 400 plus nothing is 400. So that's how we get to 400 there. And 10 squared, you should know, is 100. So this is 100 pi. 400 pi minus 100 pi is 300 pi. So that's the difference in their areas. Unfortunately, that's not one of our answer choices. So in light of that, we're actually going to have to substitute 3.14 in for pi. So this becomes 300 times 3.14. All right, let's work that off to the side because that's actually pretty tedious to do. We have 300 times 3.14. All right, we're multiplying a whole number, notably 300, by a decimal, notably 3.14. In order to proceed, what we want to do is clear this decimal from 3.14 by shifting it 2 times to the right. And this problem becomes this. 314 times 300. Once we work that out, we'll take our decimal place that we shifted 2 times to the right here, and we'll shift it 2 times to the left over here. All right, so let's go ahead and do this. This is actually going to be very easy since we have 2 zeros here. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with this 0, we have to bring in a 0 placeholder. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with this 3, we have to bring in 2 0 placeholders. 3 times 4 is 12. Carry a 1. 3 times 1 is 3 plus 1 is 4. And 3 times 3 is 9. Let's add these up. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus 2 is 2. 0 plus 4 is 4. 9 plus nothing is 9. Bring in our two decimals. 1, 2. So we can see that 300 times 3.14 is 942. And this is going to be inches squared since it's referring to area. And we can see that that is answer choice B. All right, so that's that one. All right, so 14 says if 4 factorial is the same as 4 times 3 times 2 times 1, simplify the following expression. 12 factorial over 2 factorial times 9 factorial. Again, our expression is 12 factorial over 2 factorial times 9 factorial. Let me explain what factorials are, even though I try to do it right here. A factorial means take the number that's given, so 5 in this case, and multiply it by all the values less than 5 until you get to 1. So 5 factorial is the same as 5 times 4 times 3 times 2 times 1. And if you multiply all that together, you'll get a real value. All right, so in light of that, we should say 12 factorial is the same as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial. And I'm going to put that in parentheses so it's clear that these are two different factorials. 2 times 1. And then 9 factorial, that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you might be saying to yourself, well, I'm not going to work all this out. This would take me too long. Of course, you don't have to. We can cross out corresponding values in our numerator and denominator. So we can cross out these 9s, these 8s, these 7s, these 6s, 5s, 4s, 3s, 2s, and 1s. So this becomes 12 times 11 times 10 over 2 times 1. And this problem is actually much more manageable to do. Again, 2 times 1 is just 2, but now we got to work this out. 12 times 10 is 120. What's 120 times 11? Well, I'm going to have to work that out. 0 times 1 is 0. 2 times 1 is 2. 1 times 1 is 1. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 0 is 0. 2 times 1 is 2. 1 times 1 is 1. Let's add these together now. 0 plus 0 is 0. 2 plus 0 is 2. 1 plus 2 is 3. And 1 plus nothing is 1. So this is 1320 over 2. And that's not one of our answer choices. So I'm actually going to read this as 1320 divided by 2. And we start doing this long division by asking ourselves, how many times does 2 go into 1? It doesn't. How many times does 2 go into 13 without going over? That's going to be 6 times, given that 2 times 6 is 12. 13 minus 12 is 1. And we could drop down this 2. And we can also drop down this 0. Again, 2 goes into 12 6 times. Therefore, 2 goes into 120 60 times. So 2 times 60 is 120 with no remainder. So 1320 divided by 2 is 660. And the answer to this one is D, 660. You do have to know about factorials for the ASVAB. And if you look on my channel, you will find that I have a video in regard to factorials. So please check that out if you need more help with this. All right, so 15 here says find the distance between the points -8, 10 and 10, 10. All right, so to do this, we're going to have to make use of the distance formula, and that says d, or distance, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And you might be saying to yourself, well, where do I get x1, y1, x2, y2 from? Again, those are the values of our ordered pair. So this would be x1, this would be y1, this would be x2, and this would be y2. So with those identified, all we have to do is plug them in now. Again, what is x2? x2 is right here, it's 10, minus what is x1? It's right here, it's -8. So this is 10 minus -8 squared plus, what is y2? y2 is right here, it's 10, minus, what's y1? It's right there, it's 10 squared. All right, so let's work this out. This minus minus becomes plus. So this is actually 10 plus 8, which is 18 squared. And let's keep working this out. 10 minus 10 is 0, so that's 0 squared. Well, 0 squared is just 0, so this becomes 18 squared square root. Well, this square root and this square cancel each other out, so this just becomes 18. So the distance between those 2 points is C, 18. On my reference sheet, this distance formula is there. So this is one I strongly encourage you to memorize. Again, everything on that reference sheet I would consider memorizing because you really never know what you're going to see on this test. I know for a fact the distance formula does show up from time to time, and it's pretty easy to memorize, so you might as well know it and get those questions right if you see them. All right, so that's that one. All right, so 16 here says, what is the area of the shaded section of the figure below? The circles are identical and have a radius of 5 inches. In addition, they are inscribed by a rectangle. Use 3.14 for pi. All right, so to find the area of the shaded section below, we're actually going to find the area of the rectangle. And we're going to subtract it by the area of both of these circles. So that's going to be minus the area of, let's call it circle 1, as well as the area of circle 2. Well, what do we know about these circles? They're identical. So we can simplify this a little bit further to be area of the rectangle minus 2 times the area of circle 1. Again, circle 1 and circle 2 are identical. All right. How do we find the area of a rectangle? That's simply length times width. And how do we find the area of a circle? Again, in this video, we've seen that it's pi r squared. Well, we already know what r is. We're told radius is 5. So we can go ahead and plug that in very quickly. Length times width equals 2 times pi 5 squared. All right. That said, the hardest part of this problem is determining what the length and width of this rectangle is. Well, if you know what the radius of a circle is, you should be able to quickly determine the length and width of this rectangle. Because again, radius means from the edge of the circle to the center point of the circle. All right, so here's the center point. So I know this is, and let me draw a straight line here as best I can. I know this is also 5. Again, let's say this is the center point of this circle. Again, we know it has a radius of 5, so that's also 5. And from here to here, which is another radius, is also 5. So the length is 5 plus 5 plus 5 plus 5, which is 20. All right. Again, using the definition of the radius of a circle, we can also find its width. Again, from here to here is the radius of the circle. We know that's 5 according to the problem. Likewise, from here to here is another radius of the circle. We know that's 5. 5 plus 5 is 10. So the length of this rectangle is 20 and its width is 10. So let's plug that in. 20 times 10 minus 2. And let's go ahead and work out this 5 squared. 5 squared is 25. So this is 2 times 25 pi. And let's keep working this out. 20 times 10 is 200 minus, what's 2 times 25? That's going to be 50 pi. Again, in place of pi now, we can write 3.14. So this is 200 minus 50 times 3.14. I'm going to work that off to the side since I can't do it in my head. Again, that's 50 times 3.14. When you multiply a whole number by a decimal, what you want to do is clear that decimal by shifting it however many times you need to the right. And 3.14 will have to shift that decimal 2 times to the right. And this problem becomes 314 times 50, albeit with 2 decimals to shift back into the left at the end when we're done here. 0 times 4 is 0. 0 times 1 is 0. 3 times 0 is 0. Before we start multiplication with this 5, we have to bring in a 0 placeholder. 5 times 4 is 20, so we're going to drop down a 0 and carry a 2. 5 times 1 is 5, plus 2 is 7. And 3 times 5 is 15. Bring our 2 decimals back in. 1, 2. So 3.14 times 50 is 157. So this becomes 200 minus 157. And if you can't do that in your head, you can always do it off to the side very quickly. Again, this is 200 minus 157. 0 minus 7 we can't do, so we have to borrow. We can't borrow from here because it's a 0, so we're going to have to come all the way over here. This is going to become 1. This will be a 10. We'll borrow one more time, so this will be a 9, and this will be a 10. 10 minus 7 is 3. 9 minus 5 is 4. 1 minus 1 is nothing. So 200 minus 157 is 43. All right, so we can see the answer to this one is 43A. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Again, let me say this. You have to memorize the formulas on my reference sheet in order to be successful on the ASVAB. So if you go into the test and you're not familiar with those formulas, you'll find the test very difficult. That said, if you learn those formulas and you take my practice test, there should be no surprises on test day. If you like the content I'm creating, please consider subscribing to my channel. That always helps me out. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.